Hi, my name is Mike Craig. I'm a partner with GKW Business Solutions. I'd like to spend a few minutes talking with you about how to analyze your business using the Lean Tool Value Stream Mapping. So Value Stream Map is a tool that is used within the Lean industry to help businesses understand what is the potential options within the process for improvements. We use this virtually in all assignments that we have with clients. And we do it for two reasons. One, it helps my partner and I understand what the process looks like, and it helps the client understand where the opportunities are within the process to eliminate waste. Typically, we start up here in the right-hand corner. Who are the customers that are utilizing this process? How do orders come in? How does it get processed through the MRP ERP system? How are orders placed with the vendors for raw material? Delivery of raw material, and where we really get focused is on the manufacturing process. In this particular case, there are 5 operations in this process. There's a machining 1 op, a machining 2 op, there's a plating operation, sanding operation, and then assembly. And we spend time with the team to understand what the key inputs are based on this particular process. And when I say inputs, what are they currently experiencing as far as the conditions in each of these operations? For instance, the first machining operation, we start with cycle time. Cycle time equals value added time, and what that means is what's the time to take the part and machine it from a piece of raw material to a sellable part. And so in this particular case, the cycle time is 180 seconds. The crew size is 2. The changeover is 28,800 seconds, which is 8 hours. Uptime is 95%. They have 10% in scrap, and we also track the available seconds within the process based on the schedule. We also track what size of lot size is pushed through the process. This is your typical batch and queue push process, and they're running 1,000-piece lot sizes. We gather the same information for the second op, the third op, the fourth op, and the fifth op. And what this does is it allows us to quickly look and identify where the opportunities are. For instance, here the setup is an opportunity. The scrap here at 20% is an opportunity. And so we take the information and we determine what the lead time is to get 1,000 pieces through this process. And the current lead time, based on the way that the shop is ran, this process is ran 24 hours a day, it takes 25 days to get 1,000 pieces through the process. We also look at what's called the value added ratio. Value added ratio is the value added time, and remember, that's the amount of time it takes to produce a sellable part. And we divide that into non-value added time, which is the time to set up the part. That's time related to move material into the line. That's time where the material is waiting to get into the next operation, which is called queue time. And so we take the VA divided by the NVA, and we calculate what's called a value added ratio. This is what's called the baseline of the current operation, and the VA ratio is 1/10 of 1% for this particular operation. It's not unusual for the operation to be less than 1%. The point is we use this as a baseline to measure improvement. So once we have the current state map completed, we continue the discussion with the team. This is a cross-functional team that's pulled together to help identify the opportunities and also help us understand what the financial impact of each of these activities can be. We typically take the identified opportunities and we divide them into phases. In this particular operation, we identified 3 phases of improvements, and we'll call phase 1 JIT 1 or just in time 1. Then that's green, the yellow is JIT 2, phase 2, and the red is JIT 3, which is phase 3. If we focus strictly on phase 1, the first identified opportunity is to take and reduce the setup on operation 1, which is a machining operation. If you recall, it currently takes 8 hours to set up a machine. we're suggesting through single minute exchange of dies that we can reduce the setup to 10 minutes. What that allows us to do is to cut the lot sizes. So the second process change would be to cut the lot sizes from 1,000 pieces to 200 pieces. This is really important because typically businesses run larger lot sizes to accommodate the large setups. They want to amortize the setup time against as many pieces as they can. Historically, that's how businesses handled setups. Today, it's more important, in my mind, that you're able to run the right product in this right sequence based on the customer needs. The only way to do that is to be able to get in and out of the machine quickly by reducing your setup time, and also when you're in the machine, you run smaller lot sizes. Very, very important, and I'll explain a little bit more about that as we move down the line through this process. The third operation is to put in a pull system from finished goods to operation 1. We'll call that a pull system in a grocery store, and I'll explain what that means next. So now we have a future state map that's been updated with the changes that were identified by the team. The first change was to take and reduce the setup to 30 minutes. Second was to go to 200-piece lot sizes. And the third was to put in a pull system. And the pull system is significant because what this means is when an order is shipped to the customer and it hits the minimum, a Kanban card or a Kanban signal is generated. It goes back to the first operation and it says make 200 more of this particular product. So what this is saying is we're actually making product as the customer uses it, as opposed to using a schedule based on a forecast that is invariably wrong most of the time. And so that is significant. As we walk the process, it's also important to know that we've reduced the lead time from 25 days down to 5 days. That is a very important point because if I'm able to make the product quicker, make what the customer needs when he needs it, make it quicker, ship it on time, then I can get paid quicker. And so that's what's called order to cash, and that significantly improves the cash flow of the business. The next thing we look at is what changed with the VA ratio. If you remember, the current state was 0.1 or 1/10 of 1%. The change to future state takes it to 0.5. The change between the two is 0.4, and that's a 400% improvement on flow of product based on current state to future state. So this is where it gets a little bit different. Most practitioners are able to generate a value stream map just like we looked at. And when they talk with the client will typically ask, that's good stuff, what's the return based on what I need to pay you to get the work done? And typically it's an estimate. The practitioner might say 2 to 4 times based on what is paid me to take care of assisting you with the process. The punchline is it's an estimate, and it's no more than an estimate. What GKW Business Solution does is we've built a model that helps us quantify and qualify what the benefit is to the organization. So in the same meeting with the same team, we take the identified items from the previous process change from current state to future state, and we identify what the financial impact is for each of those items over a 5-year window. So you've got elimination of overtime because we're running smaller lot sizes. Margin improves because we're running smaller lot sizes. Usually, when you cut lot sizes, after you've used setup reduction tools, you can cut finished goods as well and reduce that and that will generate cash. It's a one-time improvement, but it is a direct improvement to cash flow. In this case, we estimated $200,000 worth of finished goods reduction. Lead time reduction, order to cash. This is where we took a lead time from 25 days to 5 days. And by building the right product in the right sequence, shipping it right away, we get paid quicker, and we're estimating a $100,000 improvement in cash flow for that. And then we created straight time capacity, which allowed us to bring new orders in from different customers and load them on the existing equipment using straight time capacity. We also take into consideration what the CapEx is, what's the capital required to implement, in this case, setup reduction, and we capture this information over 5 years, and then we load it into a model. The model is used to generate the impact to the income statement, the balance sheet, and then also generate charts. We look at 4 particular impact items as it relates to going from current state to future state. What's the impact to gross margin? What's the impact to EBITDA? What's the net cash flow after CapEx? And then what's cumulative impact to cash flow? And so in this particular example, there was a 0.24% improvement in margin. EBITDA improves. This is the baseline. The EBITDA from current state was $500,000 a year. The improvements will generate an additional $60,000 each year over the 5-year period, creating $300,000 of incremental EBITDA year over year based on the changes. We look at net cash flow after CapEx. Current state is $3.5 million of positive cash flow. You've got an improvement of $360,000. If we went back and looked at the prior slide, it's $200,000 of finished goods inventory reduction, $100,000 worth of order to cash improvements due to reduced lead time, and then $60,000 of operational EBITDA. And then you see the additional $60,000 per year based on operational improvements as outlined up here. What that means from a cumulative cash flow standpoint is this project will generate $600,000 in positive cash, incremental cash, over the 5-year window. The next chart that the model generates is what's called a sensitivity analysis, and we look at gross margin, cash flow, and EBITDA, and we ask the client if the model is generated the likely case based on the previous slides, what would be the plus or minus to the likely case? In other words, what would worst case look like and what would best case look like? And the client said, well, why don't we go minus 50% to likely and plus 50% to likely? So we load those percentages in and the model calculates these charts. The point is by talking with the team and the owner, we can say that we believe that based on the data that was provided by the team, by the way, that there's buy-in and that we can estimate that somewhere here in the middle is where the result is going to fall. And so we show them the impact of margin, the impact of cash flow, and then impact EBITDA. And it gives them a range of where the improvements can fall. The last slide is calculating the project ROI. As I mentioned earlier, typically the owner will ask after the future state is identified and what the changes are, what is the ROI? As I mentioned, most practitioners will provide estimates. We're providing estimates, but we're providing more detail to support the estimate, and we feel like we have a much better idea of where that return is going to be for the business. So the hours that we believe it will take to support the team to move from current state to future state is calculated and is loaded into the model, and it's compared to the cash flow generated by the changes. And it gives you a window of where the ROI is going to be, and that's the point. There's a couple of key points that I need to make as we wrap this up. Number one, this is very unique to GKW Business Solutions. Most practitioners aren't able to give you this level of return, to give you something to rely on, to feel comfortable that there is value in what we bring to the table. The second item is we're a little bit different. We don't coach from the conference room. We work with the client and we develop the plan, and then we go to the floor and we work with the team on why change is necessary. In this case, setup reduction is critical. We would go to the floor and work with the operator on determining what the setup change should look like, but more importantly, explaining why setup reduction is necessary. This is Mike from GKW Business Solutions. If we can be of assistance, please reach out. Thank you for your time.